Grade 11
Hello,
functions
grade 11s. I hope
revision.
that you guys are good and you are preparing for your final exams. Right. So I just want us to do a quick revision on functions. Right. So what we need to know first is how many functions are we dealing with at grade 11s? Right. So we're dealing with 4. So the first one would be the straight line or linear function. Right, so that is the first one. What is the second one? That will be your parabola. What will be your third one? Your third one will be a hyperbola. And the last one would be an what? An exponential functions. Right, so before you now begin to answer any questions on functions, you need to know now what is a straight line function and what does it look like. Right, so let's first start with the straight line functions, number 1. Right, so the general equation of a straight line function will be y is equals to mx plus c. Right, you need to know what the parameters now mean in order for you to be able to work with functions. Now, what is y? This will be the y value in a straight line function. And what is m? M will represent your gradient. Right, and how do we calculate m? We calculate m using the formula m is equals to y2 minus y1 over x2 minus x1. Right, so here what will be your x? Your x will represent your x values in the straight line function. And what would be c? Now c will represent your y-intercept. Why does c represent our y-intercept? Because now when we want the y-intercept, we make what? X to be equals to 0, right? So if you make x to be equals to 0, that will make the whole thing to be 0 and will be remaining with c. So c would represent your y-intercept, right? So, right. What's another thing that you need to know when dealing with a straight line function? You need to know what the graph would look like if your gradient is positive. So if we have a gradient that is greater than 0 or a positive gradient, we are expecting the function to be an increasing function, right? So that will come from your left there up there and to your right. Then what if the gradient is now negative or less than 0? So we are expecting your function there to actually be a decreasing function. Right, so that is the difference there. It's important to note this because sometimes when you ask to calculate the gradient or the equation of a straight line, so if you get your gradient to be positive, you know that you're expecting your function to be in this kind of a shape here. So, right, let us now go to a parabola. Right, so we are dealing with your parabola. Right, so what would be the general or the standard equation of a parabola? So the standard equation of a parabola would be y is equals to ax squared plus bx plus c. Right, so this is your standard form of your parabola. Right, so here, what would your a represent? All right, so let me just go there and rewrite this again. So we have your parabola there. And we say our equation is y is equals to ax squared plus bx plus c, right? So your a here would represent what? The shape, right? So that will help us in terms of us knowing that, okay, if the value of a is positive or the value of a is greater than 0, therefore we're expecting the shape of the graph to be a concave up or a smiling graph, right? Then what if a is now negative or less than 0? Now we are expecting that graph to be concave down, right? Okay, good. Right, let us now go back to C. What does C represent? So your C here would also represent your y-intercept as per, which is also kind of the same way as your straight line function, right? How do we know this? It's because when we want the y-intercept, we make x to be 0. So if we make x to be 0 and x to be 0 here, we'll be left only with c. This would make c to be your y-intercept, right? So we also need to know the other two form of equations that we need in order to write our equation back into this form. So we have y is equals to a into x minus x1 into x minus x2. Now you use this formula here when you are given two x-intercepts. Two x-intercepts are represented as x and a certain point, right? So your x1 and your x2 would actually represent your x-intercepts. So you just choose one of the x-intercepts and you write them here. So you must know that when they come here, they will actually change signs. So it will mean that if your x-intercept is 2, then when it comes here, it will be a negative 2 because the general equation is x minus x1, right? Then what about the point? The other point, you'd put them here. So here they would share the same x value. Then what is the y here? That will be the y value of the other point, right? Okay, so now you can simply just put in the values, then first solve for a, then after that you plug in back your full points here at x1 and x2, then you now do your FOIL, then it will bring you back to this equation here, right? So what is another equation that we use in a parabola to go back to this equation here? So we use your y is equals to a into x minus p squared plus q. So this one you use when you are given a turning point. So you are given the equations of a turning point and a point. So where p would represent the x coordinate of your turning point and q will represent your y coordinate of the turning point. Okay, so you substitute that in p and q, then in the x and y you substitute the other points there. Then you solve for a. After that you substitute the other points here and your turning points, then you solve for this equation. It will give you back this equation. So what happens when you're given an equation like this and now or you're given an equation like this and you need to come back here so that you complete a square, right? So I'll do a separate video on how we complete a square, right? Okay, so let us now check here. The third function that we need to know is your hyperbola. So what is a hyperbola? So a hyperbola, the general equation will be y is equals to a over x minus p plus q, right? So what do each of these components help us with? So here, if the value of a is positive or the value of a is greater than 0, we'd expect the graph to be in the first and third quadrant, right? Then if the value of a is negative or less than 0, we are expecting our function here to be in the second and fourth quadrant, right? So you need to know these things because it helps you also to see if your answer is correct if you are asked to do an equation or find the equation of a hyperbola, right? So let us continue here with the parameters. So what does this here represent? So P will show us the asymptotes. Now, what are asymptotes? So asymptotes are now imaginary lines that the graph will approach but will never touch, right? Okay, so sometimes you're asked to write the equation of the asymptotes. So the equation of the asymptotes, the general equation of the asymptote would be x is equals to negative p for the vertical asymptote, right? So what about the y? So the horizontal asymptote will be y is equals to q. So this represents your horizontal asymptote. Okay, right. So these are your asymptotes. So we always have two asymptotes on a hyperbola. So even if they can exclude these values here, it will mean that now your asymptotes are actually equals to 0. So never make that mistake of thinking that you don't have asymptotes. So in